Okay, so this is section 3.6 called Boxand-Whisker Plots. So this is after we've covered measures of central tendency, measures of dispersion, the mean, variance, and standard deviation for group data, and the uses of standard deviation and measures of position. So let's take a look at this. So a Boxand-Whisker plot gives a graphic presentation of data using 5 measures: the median, the first quartile, the third quartile, the smallest, and the largest values. Okay, what's all this about? So let's look at a picture of it. So this is called a box plot. Doesn't have the whiskers yet. Let's see, the Boxand-Whiskers plot is here. So if you look at this, what does this mean? So this is some data. Let's see, what is it? Income. This is income data, and maybe this is in thousands of dollars. So this means $85,000. This means $95,000, and this is people's income, I guess. So here we see this box, and these are called the whiskers. So what is this trying to show us? So, well, you can see that this place here, or this line here, is the median. Okay? And you can see that they point here. This is the first quartile, and this is the third quartile. Okay? And then you can see here, the end here, this is called the largest value within the 2 inner fences, whatever that means. And this is called an outlier. And this is the smallest value within the 2 inner fences. Okay, so anyway, this is called a Boxand-Whiskers diagram, and it's supposed to give you an idea of the kind of how the data exists, or how it lies, or we say how it's distributed. Okay, so for example, here I can see, because this line is at about 85 or 86 or 87, so I'll know that I can estimate that the median is around 86 or so. The first quartile tells me that, or let's say the third quartile tells me that, it's about at 100, say. So that maybe about 102 or 103 tells me that 25% of all the scores, or all the incomes, are above that point, and 75% are below that point. The first quartile tells me that, which is about 76, tells me that 25% of all incomes are less than $76,000, and 75% of all incomes are above $76,000. So this is a kind of measure. The distance from here to here is a kind of measure of how spread out the data is. For example, if this was very narrow, for example, just from here to here, we'd know that all the incomes are most of the incomes are very close to each other. Whereas if it was spread out, say, from here to here, that is, the first quartile was down here and the third quartile was up here, we'd say that that population has much more varying incomes. So just by looking at this, you can sort of get a feeling for how the income is distributed. And furthermore, of course, the median means the 50% point, which means that 50% of the income is above whatever this is, 86, and 50% is below that. And these are, we're going to talk about this in a minute, and then this one is an outlier. It's far away from the rest of the data. So this person's earning a lot, and they're unusual. All right, let's go back and look at this carefully. A Boxand-Whisker plot gives a graphic presentation of data using 5 measures: the median, the first quartile, the third quartile, and the smallest and largest values in the data set between the lower and upper inner fences. The inner fences are explained in section 3.24 below. 3-24 below. Let's look at that if we can. So here's the definition of the inner fence. The following data are the incomes in thousands of dollars for a sample of 12 households. Construct a Boxand-Whisker plot. Or maybe, anyway, let's look at this. Step 1. First, rank the data in increasing order and calculate the values of the median and first quartile, the third quartile, and the inner quartile range. So here they're ranked in order from smallest to largest. Then we can calculate the median by, well, we talked about that already, but anyway, there's how many pieces of data here? 12, so the median is going to be between the 6th and the 7th. So 1, 2, 3, 4, 5, 6. So it's going to be between here and here. It's the average between here and here, so it's 87. The lower quartile, they're 12, so 1/4 of the data is 4. So we want 1, 2, 3, 4, 70. I'm sorry, we want 3. I'm sorry, it's 3. So it's, but we have to go between 75 and 79. So it's right here. So that's 77. The upper quartile is between these two. And the IQR range is this value minus this value. So 101 minus that. So this is 24. So that gives me an idea of the spread. That's the spread. So that's the IQR. Step 2, find the points that are 1.5 times the IQR below Q1 and 1.5 times the IQR above Q3. So in other words, what we do is, going back to this picture, we say here, here's the third quartile. The IQR here is what, about 20, let's say it's not exactly 25, but let's say it's 25. So let's say the IQR is 25. So what you do is you go from here, and you go 1.5 times the IQR. So we just said the IQR is about 25, so 1.5 times that is about 37 or something like that. 38, 37. So what you're going to do is you're going to go up 37 or up 38 from here. So from here, this is about 100. So you're going to go up to about 135 or something like that. And that's called the inner fence. Okay? The upper inner fence. So the upper inner fence is up there, and the lower inner fence is 41. Okay, what else do they want us to do? The Boxand-Whisker plot. So 3, determine the smallest and largest values in the given data set within the two inner fences. So the smallest and largest, so the smallest one and the largest one between 41 and 137. So smallest one between 41 and 147 is 69, and the largest one between 41 and 137 is 112. 69 and 112. Draw a horizontal line and mark the income levels on it such that all values are, so do this. And then this is where the lower whisker is, 69. Okay, so it's you go down as far as 41, but you want to find the last piece of data that's within that range between 41 and 137. So that's 69, and on the top it's 112. So you put the whiskers there. 69 is up here, and 112 is here. And that is the Boxand-Whiskers plot. And therefore, from anything outside of there, between here and here, we can identify as an outlier. That's going to be the definition of the outlier here. Okay, so actually, yeah, that's good enough. Okay, so you can take a look at this yourself. Okay.